Yo guys, welcome back. So today we are going to be doing past papers in preparation for tomorrow's exam. I'm hoping you guys can hear me properly. So yeah, I'm just planning to do as many papers as I can. Yeah, that's basically what we will do in today's live stream. I'm hoping you've already gone through the notes, the definitions, everything, and then right now you're just going through the questions. So yeah, I did a stream yesterday whereby I did like some hard topics, difficult topics. I did a few past papers that time, but then yeah. Okay, so I think without wasting any time, let's just begin with the first paper. So I'm starting off with the 2021 May-June variant 1.3. Okay, so yeah, I'll be looking at the chat at the same time. So if you don't understand a particular topic, then yeah, I'll explain more. So yeah, you can do this paper alongside me, or you can just watch me do it. Any helps. Okay. Hello everybody. Hello. So yeah, I put a poll on my community post whether I should do this type of video, and the response was I should. So yeah, I think it's beneficial. Past papers is the best way to revise after you have read your notes. So after you've read your notes, then this is the best way. So yeah, let's begin actually. Let's stop wasting time and let's begin. So as I said, we're going to start off with the May-June 2021 variant 1.3. We're going to do every question. Let's see how many papers we can do. But the agenda is to do as many as I can. I don't have a certain goal, but I'll try my best. Okay. So yeah, you can do this paper alongside with me. This is May-June 2021. So yeah, let's do this. Okay, first question. GRETA has a computer, okay, that she uses for schoolwork. Now, the first usual lines, hello everybody, is usually not that relevant, right? Sometimes they just give irrelevant information. But still, you got to read them in case you miss out any information. So it starts off by saying the computer has a media access control. Okay, this looks like the MAC address that they've given us. And it says tick to show whether the MAC address is initially assigned to the computer by the network, the manufacturer, or the user. Okay. Now, the one media access control, the MAC address is always set by the manufacturer. Okay, the IP address is set by the ISP. Okay, none of them is set by the user right here, so this one is totally out. So I have an input device topic test tomorrow. We'll be doing many questions on input devices, so if that helps. Yeah, anyway, so the first question is a manufacturer. Okay, and also sometimes they can ask you to actually identify the uses of a MAC address. So when you're talking about that, you can also say that this is set by the manufacturer. Okay, the next question, the values in the MAC address are hexadecimal values. Okay, yeah, convert the 3 given hexadecimal values into 8-bit binary. So this is quite simple. Okay, so how are you going to do this? Remember, there's a simple step to convert any hexadecimal value into binary. So first things first, you're going to separate them into 2 parts. So we have 4 and we have 1. Okay, next thing you're going to do is 1 2 4 8. This is like, you just have to remember this is the way, like, you do for any question. Okay, 1 2 4 8. Okay, just do this. Okay, so we have 1 here, we have 4 here, then we wrote 1 2 4 8. After this, okay, because it's an 8-bit binary, so of course they should be 8 digits. Okay, read the chat please. Can you do another paper? I've already done this one. Now I'll be doing many papers, right? So maybe if because I just started off with this, so let's just get this done. But you can suggest the next paper. Okay, my day is good. Smart on. Yeah, so the first question is usually about conversions, so not that hard. So yeah, so 1 4. Then what do you have to do next? You have to make the number 4. And how will I do this? Meaning, to make the number 4, I just have to put a 1 here. The rest will be 0. Okay, if you don't understand this, I've made so many videos on this, so yeah. Okay, we move on. Then this one will be like this. Okay, so that is the first one. Okay, that is the first one. So that should be the answer for the first one. So be careful you don't misplace the one. I know it's really easy, but then sometimes you can really make silly mistakes and then mess up. Okay, the next one, A0. Let me rub this one. Let me rub this one. And then do A0. Alright, so same thing. So A and then 0. Split 1, 2, 4, 8. 1, 2, 4, 8. Now A in hexadecimal is 10. Okay. Okay, so yeah, so 1, 2, 4, 8. So to get 0, of course everything will be 0 then. Okay, and to get 10 it will be 8 plus 2, so 0, 1, 0, 1. Okay, this is another example. I heard there is going to be a 10 marker in May June paper about sensitivity or something similar, including systems, but there could be a 10 marker. A 10 marker. I haven't seen any 10 marker usually. And if it's sensors, then that's quite straightforward. But usually they come 7 marks, 6 marks. But it's usually easy. If it's sensors, it'll be easy. I don't think it's sensitivity. There is nothing like sensitivity. It should be maybe sensors. Okay, so no, I don't think about sensitivity. But I don't know where you're getting those sources from, but if it is, then I doubt so. 10 mark. Okay, so yeah, that's the answer for this one. Okay, I will move on to C9. Let's move on to C9. Okay, you can do this by yourself. Okay, and then maybe like mute the stream and also do it alongside. So C9, again, same way you split, right? 1, 2, 4, 8. 1, 2, 4, 8. C is what number? C, remember, A is 10, B is 11, so C will be 12. Okay, C will be 12. So we need to make 12. So that will be 8 plus 4, which is 12. So 1, 1, 0, 0. To make 9, we can do 8 plus 1, so 0 this. Okay, so these are the answers for the first question. So that's that. Do I take requests? Yes, I do. I mean, you can put the paper after this, we can do yours. Okay, so there's no like particular order, but yeah. Do I have the Feb March? I do have the Feb March, and I put a community post saying that I'm sending that to you, but we'll see. But you see, the thing is that the marking scheme is so inconsistent for computer science. If I do Feb March, then yeah, but we'll see. Okay, then the next one, convert the two given hexadecimals into denary. Okay, so now to convert a hexadecimal to denary, remember hexadecimal is base 16, right? So to convert this, you would do 9 times 1 and 2 times 16. Okay, so 2 times 16 is 32 plus 9, which is 41. So the answer is 41. Denary is base 10. Okay, that's the two differences. And then C8, let's go C8. So you will do 8 times 1, and C is 12, so 12 times 16. Now I'll have to do long multiplication, so that will be 7, 2, 1, 2, 9, 192 plus 8, which is 200. Yeah, you need to learn your multiplication, because sometimes people ignore the fact that, you know, such simple questions can come and then you mess up. Like such types of questions, they really test on your long division, your multiplication. Can you please help me in computer architecture? Well, I've made so many videos on that. Actually, the stream yesterday, I talked about that. But then we'll do past paper questions, so don't worry. Do you have any resources on what we need to know exactly? Well, just go over the syllabus. The syllabus content is the best way. And then know each definition from your textbook. Okay? Yeah, okay. Anyway, we move on. So GRETA stores data on several offline storage devices, including an external hard disk drive. So that's a HDD. So we have HDD, SSD, and we have the USB, which are storage devices. Okay, and then CDs are optical devices. Okay. Yeah. Identify the type of storage for each device. External HDD, I've just mentioned like almost one of them. So HDD is a magnetic storage. Okay, USB is a solid state. Okay, solid state, and then CD is optical, as I said. Okay, these ones, the theory you just need to know like by revising. Yeah. How many papers do I think I'll do? I don't know. Let's see. We shall see. We shall see. Can we use a calculator? No. Calculator is not allowed. That's the tricky part. I don't know why they don't allow, but I think some calculators can do binary and denary and all. So yeah. But approximately, maybe, I don't know. Let's see. Actually, I have no idea. I'm just gonna go with the flow, and we shall see. Okay. Describe the operation of a HDD. Okay, so I've done this yesterday, but let's do this again. Okay. Let's do how we do this. So can you do the question on how CD is read? Yeah, we'll do this. I think when we're doing the past papers, we'll cover almost every topic, so don't worry about that. CDs is quite straightforward. Okay, bits and dumps is what you need to mention, then circular, the type of laser, and you'll get your marks. But let's see. Okay, so HDD, I'm just going to be giving in point form so I can save time. HDD, remember, we said yesterday that it uses magnetic properties. Okay, it uses magnetic properties, and it has something called platters. So you say it has platters. Okay, platters in this case is something that moves around in tracks. Okay, so these platters move in a circular direction or move into tracks. Okay, so there are tracks on the HDD that move around, and then that's how it works. Will I do econ? Yeah, I'll try to do econ. I don't know. I'll try. How do you answer sensor questions? There was a video that I talked about that. I think in the live stream I went through it briefly, but yeah, you can go and have a look at that. But if it comes in this papers, then I'll let you know. So yeah, let's see. We'll do all these questions that you guys are asking, so we'll take it one by at a time. This is not like a doubts live stream, but instead we'll just do past papers. Let's see how many you can do. Okay, number 3. We move on. Number 3. The next thing we said, HDD, they have a read-write arm. It has a read-write arm that uses magnetic properties. Okay, so it uses something called electromagnets. If I'm going too slow or too fast, let me know. Yeah. Okay, so it has platters move into tracks, it has a read-write arm, and it has electromagnets. Okay, that is what you need to know. Okay, we move on. Next question. This question always tested. I mean, if compression comes, then it's always usually how does compression work? That's always how it works. Okay, so yeah, so Jolene displays videos on her website. Okay, and she uses lossy compression. So we have two types of compressions that you need to know. We have lossy compression, we have lossless compression. Okay, the difference between the two is lossy compression is permanently deleted, while lossless, okay, is not permanently deleted. Okay, so let's move on. Describe how lossy compression reduces the file size of the videos. First thing you need to say, it uses an algorithm. There's something called compression algorithm. Yeah, I'm gonna speed up through the easy questions. So here you'd say compression algorithm. First mark you get compression algorithm. Sometimes you can also mention that which type of algorithm. There's something called the RLE algorithm. Okay, so you can remember that, try to remember that. Sometimes if you can't think of another mark, then always write RLE algorithm. That's the one that is used in compression. The next thing you would say, because it is lossy compression, you can say data is permanently deleted. Okay, data is permanently deleted. That will give you your 3 marks. That one would work for almost all of the questions. Say 2 reasons why Jolene would use lossy rather than lossless. Now, the reason why someone would use lossy is either maybe because you want to take up less storage. Okay, because it's permanently deleted, right? So you could say uses less storage. That's the first one. And the next one, you could say it also takes up less bandwidth. Now bandwidth, if you know, is basically the lag or the buffering, okay, to download or upload something. So you could just say less bandwidth. Thoughts on physics paper 5? Well, we're doing computer science, so let's focus on computer science. But it was It was okay. Okay, so we move on. Yeah, these are the easy questions. The first few pages are quite easy. Okay, even the fill in the blanks, they're so direct. Okay, so usually they come out with around 6 marks. But yeah. Okay. Okay, let's move on. An optical mouse is a type of input device. So yeah, we were talking about this in yesterday's stream. Now, if they bring input or output devices, usually it's fill in the blanks. It's like matching or something like that, because you can't go over every aspect of a mouse or every aspect of input devices, but general knowledge would help here. Okay, so complete the paragraph about the operation of an optical mouse using the most appropriate term given from the list. Not all terms can be used. Okay, let's go. An optical mouse shines and let's see, the optical mouse. So even if you just look at the mouse, right, there's always that light that comes out of there. Which light is that? Let's see, it can't be a ball, it can't be a battery, it can't be LCD, it has to be LED light. It's a LED light, that red light. Okay, from the bottom of the mouse onto the surface, the light bounces straight back from the surface into a photoelectric cell. This has a lens. Okay, and the purpose of the lens, it magnifies the reflected light onto, allow the detection of smaller movement. When a button on the mouse is clicked, let's see, no USB, no, a micro switch, it could be micro switch, yes, it is micro switch, so micro switch is pressed. Okay, then let's see, which a matrix connection, no, a USB connection. Yeah, okay, so a USB connection is then done. Okay, so some people are giving some past paper suggestions. Yeah, we'll try to do as many as you can. So yeah, so March 2019, yeah, we'll have a look at that. Identify 2 other input devices that can be used to enter data into a computer. Any input devices, so you can see how easy that is. So you could talk about a keyboard, you could talk about a microphone. Okay, a microphone is an input device. Okay, a microphone is an input device, so don't forget that. Sometimes people say that's an output device, but remember, the microphone is connected to the speaker. Yeah, so just to tell you. Okay, another type of question here is error checking methods. And or actually this one is security threats, but let's see. So Spencer finds out that his online music account has been accessed by an unauthorized person. He believes his personal data for the account were obtained using phishing. Okay, so we have phishing, we have farming. Sometimes they can ask you the difference between the two. You need to know they both are legitimate looking emails, but one is downloaded onto the computer, while the other is when you click on something. Okay, but explain how personal data could be used to obtain phishing. So here, what the points you need to say is it is a legitimate looking email. Like sometimes if you go to your email, you will find some very fishy emails, right? And those types of emails, right, when you click on them, they redirect you. Okay, they redirect you. So redirect you to a fake bogus website, or you could just say fake website, it still works. Okay, so it'll redirect you to the website, and then its intention would be to steal data. So number 3, to obtain personal info. So those are the 3 steps. And you see, the thing about computer science, right, is that this same question can come in another form. Like it could come in the form as, what's the difference between phishing and farming? Okay, so that's the main thing. Okay, so it's almost the same thing. That's why doing past papers for computer science is really helpful. Give 2 other security risks that could have been done. Now here the keyword is internet security. So you cannot give stuff like biometrics. Okay, that is not internet. The only things that are internet could be farming. Okay, farming, and then it could be hacking. Hacking is done online. It could also be what is spyware? Yeah, spyware is when you monitor the key presses, so it could also be that. What is covered in security? So the main things you need to know about security: you need to know about phishing, you need to know about farming, you need to know about hacking, viruses, and spyware. That's the main 5 one, if I can recall correctly. Then apart from that, you need to also know about the biometrics, strong passwords, encryption, and so on and so forth. You're so unprepared for tomorrow. Don't worry, don't worry. You know, computer science, you can, even if you revise the day before, right, then you can actually pass. You can pass easily. Just doing papers, because it's so repetitive, almost all questions, so don't worry. Yeah, hacking, cracking, keylogging. Yeah. Okay. Those are almost similar, right? Hacking, cracking, keylogging. But yeah, they all are security threats. Okay, we move on. 6 statements are given about programming languages. Okay, so we have some programming languages. Okay, and here they've said the programming languages are high level language, assembly language, and machine code. Okay, it says tick to show whether each statement applies to high level language, assembly language, or machine code. And then yeah, some can have more than one. So these ones are really tricky, okay, because sometimes it has only one, sometimes it has two, sometimes it has three. So in these types of questions, be really keen. These are the types of questions where you have to, where like the very smart students lose marks. So let's have a look at this. Okay, it requires a translator to be processed by a computer. Remember, high level language is easy to understand. If it is easy to understand, that means of course we'll need a translator. Assembly language, also assembly language, you will need a translator. And we studied this when talking about translators. We said we have the compiler, we have the interpreter, and we have the assembler. So assembly language will follow under the assembler. So of course you will need a translator. It is an example of a low level language. Assembly language is a low level language. Machine code is a low level language. Low level languages are harder to understand. Okay, the key difference between a high level language and a low level language is that high level languages are more close to human language, and the low level language is more close to the computer. So it'll be like binary digits and stuff like that. It uses mnemonics. That would be only assembly language. Okay, mnemonics not in high level language, because remember, high level language is just like the human language. Okay, it uses English like statements. That should be the high level language, because we said it's close to the humans language. It can be used to directly manipulate hardware in the computer. Which one is that? That would be assembly and machine. Okay, so all the low level languages can manipulate the hardware because it directly translates in computer stuff. It is portable. Is only high level language. The other ones not portable. When will I upload physics part 2? I am not sure. I've been wanting to upload that, but then I haven't been finding the time to. But I'll try my best, because physics is next week. But let's see. I might do a stream like this. But for now, let's just focus on computer science. Do I take one-on-one classes? No, I don't. YouTube is the only platform that I teach. Anyway, 4 7-bit binary values are transmitted from one computer to another. Party bit, so sometimes it's really excessive information that is not even needed. But just read it, because you see, you can finish this paper in like 30 minutes. If you don't read these types of stuff, that irrelevant stuff, you can finish. Okay, but then it's advisable to read all this. Okay, types of parity. Okay, this is the easiest question. You literally have to just count the number of ones. So here we have 1 2 3 4 5. What type of parity? This is an odd parity. Okay, this one has 1 2. This is an even parity. This one has 1 2 3 4. This is even. 1 2 3. This is odd. Okay, so quite simple. Okay, state why the parity check does not identify error. So we say there's something called a transposition error. Okay, or transposition of bits. Okay, so this one you just need to recognize. So you can remember these answers in your head while doing these papers. Okay, you can remember this. Okay, anyway, yeah, so a data is sent using a serial duplex data transmission. Serial means single wire, duplex means in both directions. Okay, so describe how data is sent using serial duplex. So first thing you would say, you would describe a serial transmission. Okay, so how you describe that is you just say 1 bit over a single wire. That itself will just give you 2 marks. You know, in computer science, you can literally just write 2 lines, right, and still get all the 4 marks, because they look at specific stuff. Like for serial, they look at 1 bit at a time, single wire. For duplex, they look at both directions at the same time. Okay, so you just say here, both directions at the same time. Okay, an example for full duplex is your phone. Like when you're talking to someone, you can talk simultaneously at the same time. Okay, so that is an example of that. Yeah, but yeah, I'm so unprepared, I don't know what to do. Don't worry, just do past papers, know your content, your definitions, and you'll be good to go. Okay, go over the syllabus again and again. Okay, so we move on. State one drawback of using serial data transmission. One drawback of serial data transmission is that it is slower. Okay, it is slower compared to a parallel. They can ask you the difference between serial data transmission and parallel data transmission. I'm going to quickly just go over that. Serial data transmission is a single wire. First of all, it's used in long distances. Okay, it is more cheaper than parallel. The parallel data transmission is for fast stuff, you know, short distances, and also no additional data is sent. Okay, so yeah, we move on. Macro uses his computer for work. The data he uses on a daily basis is valuable to his business. Macro is concerned about his data being accidentally damaged, human error, such as incorrectly removing external devices. In one way that the data can be accidentally damaged, okay, so human error is one way that it could be accidentally damaged. Give another way. So another one you could say is floods, and you can say power outage. Okay, power outage, floods. Okay, or you could also say natural disaster, fire, hardware failure, anything like that. There are quite a lot. Removing storage devices correctly from the computer can help prevent data being accidentally damaged. Give 2 other ways that accidental damage can be prevented. So regular backups is one of them, right? Regular backups. So you could just say backup data, but nowadays, like, we have like iCloud and stuff which automatically backs up, so you know there's no need of that. So yeah, backup data. Okay, what else? Okay, so that's one way. Then another way is that you can also say, like, you do not, you know, have a firebox, for example, or do not drink any liquid next to your computer. So you can talk about the physical aspects, or you could just say surge protection. Surge protection is like basically it just protects your UPS if in case any power outage happens. So that would work. Okay, that would work. Surge protection. Okay, so we move on. Okay, so logic gates will for sure come. Okay, will for sure come. Okay, because this type of question always usually comes. So let's see. 2 NOT gates are used in the given logic circuit. Okay, 2 NOT gates are used in the given logic circuit. Identify 3 other logic gates that are used. Okay, so this is the NOT gate. What is this one? This one is the NOR gate. Okay, this one is the NOR gate. Then this one is the AND gate. Okay, this one is the AND gate. And then this one is finally the XOR gate. Okay, that is the XOR gate. That's not the NAND gate. The NAND gate would be this with a O. Okay, that would be O. Yeah, the XOR gate, remember, it has double. Okay, so that's what you need to know. Okay, that is what you need to know. We move on to the trace table. So the way I approach the trace table, yeah, that's correct. And not and so. No, not. You can't say not. Remember, it said there's a not gate already here. You see, that's where the tricky questions come, and that's where you lose a few marks. It says two not gates are used. You have to give apart from that. Yeah, exactly. So a tricky question there, maybe they catch you off guard there. It's a simple question, but still they catch you out there. Anyway. First things I do is label each of them. So I label each of the logic gates. Okay, so we have 1, 2, 3, 4, 5. Okay, so we have 1, 2, 3, 4, 5, and then separate in. So I've done this question before, yeah, but I'll do it again. Yeah, so 1, let's see, we start off with 1. So 1 is a NOT gate, so it'll be the opposite of B. It will be opposite of B, so that one's quite straightforward. Okay, just give me a second, let me just do this. Okay, there you go. Yeah, so 1 is a NOT gate, so it'll be opposite of B. If I'm wrong, yeah, if I'm right, so yeah, it'll be the opposite of B. So it'll be 1, 1, 0, 0, 1, 1, 0, 0. Okay, we move on to 2. 2 is what? 2 is a NOR gate. It'll be the opposite of the OR gate. Okay, it'll be the opposite of the OR gate. So the opposite of sorry, what am I saying? This is the NOR gate, so it'll be the opposite of the OR gate. So we find the OR gate and then we do the opposite. Okay, so we have to join 1 and we have to join A. Okay, and then it joins together to form the NOR gate. So we are joining 1 and A. So the way you do this is you first do the OR gate and then you do the opposite, which is the NOR gate. Okay, so let's do OR gate first. So it'll be 1, 1, 0, 0, 1, 1, 1, 1. The way I'm able to do it so easily, right, the way I'm doing it so easily is that, you see, OR gate is addition, right? So NOR gate will be the opposite of that. So just simply doing 0, 1 is just 1. Okay, so the opposite will be this: 0, 0, 1, 1, 0, 0, 0, 0. Okay, so yeah, that's straightforward. That is straightforward. We move on. We do number 3. We do this one now. Okay, so this one is combining B and it's combining C. Okay, so it's combining B and combining C. Okay, so let's combine B and C together, and this is an AND gate. So AND gate is the multiplication gate. So let's see, B and C multiplication gate. So you just do this. Okay, that's simple. Number 4, we move on to number 4. Number 4 is 2 and it's 3 joining together to actually wait, we have 4 here, which is the opposite of 3. So let's do that. So 4 is the opposite of 3, so simply just be like this. And then 5 is 4 and 2 joining together, 4 and 2, and it's a XOR gate. For the XOR gate, remember, like is 0 and unlike is 1. Okay, so we have 3 and 4, yeah, or is it 2 and 4? Yeah, 2 and 4. Okay, 2 and 4. They should give this on the same page. I don't know why they give it on other pages. I think though, if they print this, they print it on double-sided, yeah, but yeah, they should have done it on the same page. That's why it's a bit tricky. Anyway, so 2 and 4, it's a XOR gate, so this one will be 1, 1, 0, 1, 1, 1, 1, 1. And we have to identify the ones that are wrong. So this is wrong, this is wrong, this is wrong. Okay, This is wrong. Okay, so apparently there's 4 now. There's 4 that are wrong. So there's probably some mistake that's gone underway. So let's do this again. Chill. 1 second. So 1 second. Let me just rub this. Let's do this again. So B is the opposite of that. So this will be 1 1 0 0 1 1 0 0. So that's correct. 2 is this one right here. So 2 is the NOR gate of A and O. Okay, it's A and 1. A and 1. A and 1. So let's do this once again. Okay, let's you see the problem with logic gates, yeah? You make one small mistake, then you gotta do it all again. So I think I made one small error in between. So because of that, we're going to do this again. But no worries. So here 2. Okay, 2 is A and 1 together, right? This is 2, so it's joining with A and is joining with 1. So let's see, and it's a NOR gate. So first let's do the OR gate. So A and 1, so here it'll be 0 0 0. Wait, sorry, we're doing OR gate first, yeah. So we do the OR gate, so it'll be 1 1 0 0 1 1 1 1. Now we do the opposite. Okay, you can do this by yourself and then just confirm whether you got this right, because it's a bit hard to explain this, yeah, because you make one small tiny mistake of 1, then you have to do it all again. So it's no problem. Okay, 3 is B and C together. B and C, and it's a NAND gate. It's a AND gate or an AND gate? It's an AND gate. Okay, B and C together, so it'll be 0 0 0 1 0 0 0 1. Okay, we move on. 4, we do this quickly now. 4 is the opposite of 3, so we quickly do that. So 1 1 1 0 1 1 1 0, and then finally it'll be to find the last one, which is 5. It's the combination of 2 and 4 together, and it's a XOR gate, so it'll be like this. Okay, so yeah, so this is a mistake, this is all correct, this is a mistake, yeah, this is a mistake, and this is a mistake. Okay, we finally did it. Okay, so the answer is 1478. Okay, fair enough. 1478. So it took us 2 tries, but we did it right. And remember, it's only 4 marks, so be careful about that. Sometimes even the small mistakes can cost you. Okay, we move on. Okay, this one's the sensor question people were asking me. Okay, and it says, an underground car park has a system that checks the height of vehicles. A vehicle can be no higher than 1.8 meters to enter the car park. Again, irrelevant stuff, right? The system also counts the number of vehicles that have entered the car park so that it can display how many parking spaces are still available. Each parking space has red and green light above it. If a car is parked in the parking space, only the red light is on. Otherwise, only the green light is on. So sensors, okay, yeah. So here it is important, like some aspects of it, because it says, first of all, a vehicle can be no higher than 1.8 meters. That's the first thing. This chat section is going mad. I'm literally just gonna give you another timeout. Yeah, because I can't even see the main stuff. Okay, but yeah, okay, so that is that. Okay, done. Okay, let's move on. So check if a vehicle is too high. What sensor is that? To check if a vehicle is too high. Okay, you can't use a pressure sensor, you can't use a motion sensor. The best sensor for this would be infrared, I think. Infrared or light sensors, one of them. Okay, count the vehicles entering the car park. That would be a motion sensor, or a pressure sensor. Actually, a pressure sensor better. Pressure sensor, like in Minecraft, when can you tell us the different sensors? So I think there was a good summary when there was a Z Notes page, right? and there they literally summarized all the sensors that you need to know, and it's most of them is just common, like temperature sensor, you know it's temperature, right? Pressure sensor, you know it's meant for pressure. Infrared, you know it's for movement. So it's like that. Check if a vehicle is parked in the parking space. Again, this could be pressure sensor, but yeah, I think you could use pressure again, so let's use pressure again. Okay, now here is the 6-mark question. Here is the 6-mark question. I'm not going to write everything. Okay, I'm not going to write everything, but I'm going to teach you how to answer this type of question. Okay, first things first, you need to mention the sensors that we mentioned above. Okay, and you need to say that these sensors, okay, send the data to the microprocessor. Okay, isn't infrared and motion sensor basically the same thing? It is, but yeah, it is, because a motion sensor uses infrared. Okay, so that is that. 1 second, guys, 1 second. Okay, then the next thing you need to mention, is the microprocessor will convert this data. Okay, it will convert this data from analog to digital, so it uses an ADC for that. Okay, it uses an ADC for that. Okay, I'm not going to write all of this, but I'm just giving you the points. Okay, I'm just going to give you the points because it's almost the same for all of the questions. You see, all these types of sensor questions, the first thing is always usually the sensor sends data to microprocessor, almost always. Then the data is converted to analog to digital using ADC. Okay, then the data is compared with stored value. And then according to the question, like for example here, it says that each parking space has a red and green light. So if the sensor is saying that there's no one on the car park, then it will be green. If there is, then it will be red. It's as simple as that. And then in the end, always say that the process is continuous. Okay, it's always like that. So can you do questions on data transmission? I will. If it comes throughout the past paper, we'll do it. Okay, so we're not just gonna do separate types of topics, because I did a stream yesterday whereby I just did separate topics. So this right now I'm just doing all topics. Okay, so we move on. So again, let's just go straight into this. Stores data and instructions before they enter the CPU. Okay, before they enter the CPU, it's only RAM. Remember, RAM is directly accessed by the CPU, not the others. Contains a register called the accumulator, that is the ALU. Arithmetic logic unit, that is what ALU means. Manages the transmission of data and instructions to the correct components, that is the CU. Okay, that is the CU, which is the control unit. Contained within the CPU, well, only these two are contained inside the CPU. RAM is outside. RAM and ROM is outside. RAM and ROM are outside. Uses the data bus to send into CPU, that is the ALU, and also the RAM. I think even ALU. Okay, and then carries out calculations, that's the ALU. Everyone knows that ALU carries out calculations. Okay, so yeah, that's quite easy, right? That is quite easy. Okay, move on. It says the accumulator is a register that is part of the von Neumann model. Give 2 other registers that are part of the von Neumann model. Okay, so we have many registers actually. We have so many registers, but the ones part of the von Neumann that we know is the MDR, the MAR, the CIR, PC. Those are the ones in the von Neumann. So yesterday we were debating whether fetch and execute cycle and von Neumann are the same. Okay, because people told me to do von Neumann and I was explaining fetch execute. So we're done with this question. We're done with this paper, sorry. Any questions from this certain paper? Okay, just give me 1 second. I'll come back in a second. Okay, yeah, so any questions on this certain paper? I think this paper was quite easy, right? This paper was quite easy, so let's make this 1. Okay, because paper's done 1. This paper was quite easy. Can you revise the LCD projector because it's important now? If it comes in one of these questions, I'll explain that. Okay, so let's now move on to another paper. I think let's do the November papers. Let me actually just check my channel if I've done any November paper. I have done paper 1. Let's do the variant 3. I don't think I've done this one. Oh, actually, let's do the ones that you people are suggesting me. If I go back all the way up to my chat, I don't know if I'll be able to see. Yeah, I can't see the old chat. So if you have a particular paper you want me to do, okay, can you do May June 2019 paper 1 2? I'm just going to do the entire paper. I'll start with the logic gates then for you. I'll start with logic gates. Okay, so let's go May June. Yeah, so let's go over to May June. So you said May June 2019 paper 1 2. Okay, May June 2019 paper 1 2. Okay. Okay, yeah, so let's start with this. Okay, you want to start with the logic gate question? So we'll start with this. I hope this is the paper. Let me just confirm. Yeah, this is the paper. So we'll start off with the logic gate question, then we'll do the entire question. Okay, so that is what we want to do. Okay, let's do this question. Looks interesting. This is logic statements. Now logic statements, the key is to just quickly zoom into this, okay, and really study the statement correctly. That's the main idea behind this. Okay, but let's go over this in just a second. Okay, let's see. So these types of questions are quite fun, okay, because usually the logic gate questions are so simple, right? Okay, but let's do this. Okay, let's begin. So it says consider the logic statement, okay, and x, one is, okay, one if, okay, so we have this first section and this first section and then or. Okay, so let's quickly actually zoom into this. Let's quickly zoom into this, and I'll teach you. I'll make you like this type of question. Can you guys see? Let me see if you guys can see properly. Yeah. Okay, look at this. I'm gonna highlight this. Now the main trick to this question, okay, is the brackets. Okay, yeah, logic gates are freak marks, honestly, but sometimes of the questions, you know, small mistakes like in your trace table, truth table, sorry, you can mess up. Okay, but always be keen when doing the questions. Okay, anyway, so let's start off with this. Again, I said we said that the brackets is the main thing, and you can see this bracket, okay, and this bracket is inside one other bracket with an AND gate. Okay, that's the first thing I have noticed. Okay, that is the first thing I've noticed. So I can even put a 1 here. Then we have, of course, 2 here, and then the entire thing is joined by the OR gate. Okay, I hope that makes sense. I hope that makes sense. Okay, so then it's joined OR with this. So this entire thing right here and this entire thing is joined to the OR gate of this entire thing and this entire thing. Okay, it's joined with the OR gate. So the last gate should be an OR gate. So let's start by drawing this. Now my drawing would be that accurate, but let's see. Let us see. So we're going to start off with one of these brackets. You could start off with this bracket, you could start off with this bracket, and then it'll be joined with the AND gate. So let's start off with this bracket. It is saying A is 1 nor C is 1. So A, we join that together, okay, and we join it with the OR gate. Okay, let me make this much better diagram. So we join this and make an NOR gate. Sorry for the terrible drawing, but yeah, I'm using the computer, that's why. Then we draw the other one. B is not 1, okay, B is not 1. Okay, B is not 1, so we'll put the NOT gate. And it's joined with NOR, C is 1. So it's joined with NOR. Again, a NOR gate. Now, you can also label the gates, because maybe if you're not that good at drawing like me, you can label the gate. Okay, so yeah, then this is joined with an AND gate because of this, so it's joined with an AND gate. Okay, now we've done this, we go to this part. A is 1. Okay, so we're gonna say A is, oops, sorry, bad drawing, bad line. A is 1 and it's joined with that. Okay, so where will I take this here? Okay, you can see how messy this drawing is, but it is actually in fact a lot messy. And then this is joined with the OR gate. Am I talking to myself? And now a quick way to see whether you're right, you count the logic gates. 1, 2, 3, 4, 5, 6. And is it 6 marks? It is 6 marks. So that should be the answer. Hopefully you understood. The main trick to this is look at the brackets. That's the first thing you'd see. Look at the brackets. You can see this bracket is within the other one. Okay, and then it's an OR gate and then again linked with this. So that's the trick. That's the trick. Ooh, a truth table for this is going to be a big task, but we'll do this later. Let's go back to the start now. Okay, let's go back to the start now. Let's go back to the start. Okay, input and output devices is such an easy question. Identify 3 input devices. Let's not waste time here. Keyboard, mouse, and microphone. Okay, quite simple. Quite simple. Okay, keyboard, this mouse. Okay, identify 3 output devices. Again, quick, easy. Speakers, monitors, and another output device. Give me another one, printer. Okay, easy. Explain what is meant by offline storage. Offline storage simply means that it is non-volatile, meaning it's non-volatile. First things first, it is non-volatile. And you can also say it is not directly accessed by the CPU. Okay, straightforward. Okay, what is one of the letter is 0? Do we use NOT gate first? Now if it is 0, then you use a NOT gate. Yeah, if it is 1, then you don't. But I think we'll do a type of question like that if we continue. But yeah, okay, we move on. Yeah, so that's 2 marks. That should give you 2 marks. The computers in a finance company uses both primary and secondary storage. Give one example of primary storage. So we know RAM-ROM, that is primary. 2 examples of secondary we have learned is HDD, SSD. Those are the 2 you need to know. Not even gonna waste time on that. Let's move on. You see, first question is so easy, right? First 2 questions, really easy. We move on. Vanessa writes a paragraph as an answer to an examination question about the central processing unit. Use the list given to complete Vanessa's answer by inserting the correct 6 missing terms. Not all terms can be used. So it's about the computer. So let's see. The CPU processes data and instructions. An instruction is, let's see, is it executed? Is it fetched? The instruction is fetched, isn't it? And then the data is executed actually. So an instruction is fetched from, let's see, from where? Is it from the data? No. Is it from RAM? Yes, it's from RAM. Okay, it's fetched from the RAM into the PC, into the CPU, where it is then executed. Or actually, no, wait. No, it can't be executed. Once this has taken place, the instruction is then executed. Yeah. So here would be what? Here would be decoded. So yeah, fill in the blanks. I mean, you can even guess, right? You can even guess and you would still get it correct. Okay. So that should be that. Okay, so Miley wants to store a video he has created for his school project. Okay. And he considers using DVD or Blu-ray. he considers using DVD or Blu-ray. Now remember, DVD and CD use red laser. Blu-ray uses blue laser. That's one difference. Okay, so DVD, red laser. I'm just gonna write in point form, okay, so we can save time, because the main purpose, like such easy questions, you know, we're just gonna not waste time. Blue laser. Another difference we can say is let's see, DVD has two layers, okay, and a Blu-ray doesn't have, it has a single layer. So Blu-ray has a single layer, okay, and has a single layer. SSDs are a form of secondary storage that use NAND gate technology to store data. SSDs have no moving parts, they store data by flashing chips. Perfect example. Yes, perfect answer. That is perfect. Okay, that is exactly perfect. Has no moving parts, uses NAND technology, it flashes the chips. Yeah, perfect. Yeah. Okay, we move on. I need the pseudocode for the CView peer. The one I did, was it CView? No, it wasn't. Was it? Yeah, it was. We'll see when paper 2 is. I'm planning to actually do a CView peer. Anyway, we move on. Okay. Marley also needs to. Oh yes, this the one that everyone wanted me to do, isn't it? This is that question that everyone really struggles. So let's do this question. 500 pixels, 300 pixels size. The first step you always do. Calculate the pixels. First step you do, calculate the pixels. Okay, so you do 500 times 300. Again, no calculators allowed, right? So it'll be 15 and then 4 zeros. 1, 2, 3, 4. 150,000. Okay. Next thing you need to know. So Marley needs to store the 10 8-bits. So there are 10 of them. Okay. So keyword, there are 10 of them. So meaning we'll have to find for 10. Okay. Each image is 500 pixels by 300 pixels, and we have to give in megabytes. So if you watched my stream yesterday, you know we have bits, we have bytes, we have MB, we have KB, and then we have MB. We have KB and then we have MB. Okay, so bits to bytes divide by 8, and then this bytes to KB divide by 124, KB to MB divide by 124. Sorry, 1024. I meant 1024. Okay, so that's what you really need to know. So right now, what we calculated, every time you multiply the pixels, you have calculated this much in pixels. So if I multiply times 8, it will give me into bits. Okay, it will give me into bits. So 15 times 8, I'll have to do long division here. 120, isn't it? So 120, and then 1 2 3 4 zeros. But then again, we have to divide by 8 to convert it to bytes, so it will go back to 150,000 bytes. Okay. Yeah, then we have to multiply this by 10, remember, because that is only for one image. So that will be 150, 1 2 3 4, which is 1.5 million. And then to get MB, this is in bytes, we have to divide by 1000 or divide by 1024, but we're going to just save time and divide by 1000. Okay, so we're going to cancel these 3 zeros, cancel these 3 zeros. Okay, and the answer, wait, sorry, this is in bytes, so we need to first, oh yeah, so we have to actually divide by 1000 and then divide again by 1000. So this 0 and then 2 cancels, and then it'll be 1.5. Did you guys understand? Because you have to do from bytes to kilobytes, then kilobytes to megabytes. That's the reason why. Okay, we move on now. Marley prints the images for his project using an inkjet printer. Describe how an inkjet printer prints an image. So first things first, it uses something called piezoelectric. piezoelectric technology. Okay, uses piezoelectric technology. It sprays the color. Okay, it sprays that color. Yeah, it sprays that color. Okay, and then we say something called technology could be it's called technology. Okay, wait, I spelled this wrong. Technology could be used, could be something called thermal bubble, and I explained it yesterday. Okay, I explained to you, can be used, could be thermal bubble, and then because we have to give one more, you can say uses rollers. If you have an inkjet printer, you know this, because you see whenever you're printing, okay, whenever you're printing, you see your printhead moves round and round. Those are called rollers. So it will print the color, it will spray the color as it goes down. So it sprays and then rolls as it moves. That's how a inkjet printer works. Okay, you need to know the differences between inkjet and laser printer. One thing you need to know is that laser printer, it is expensive. The toner is very expensive. However, it can be used for places that are quiet, okay, because it doesn't make noises. Okay, yeah. Can you please solve question 1B in winter 2021 question paper 1-2? I have done a video on my channel on that, so you can have a look at that. But again, if we do that entire paper again, we'll go through that. Okay, so yeah, a music company wants to send a music file to many radio stations. Okay, it will send the music file the day before the release date so that the radio stations can store the file ready for release. Again, you can see first line always irrelevant, almost irrelevant. Just read it though, but irrelevant. You know, so I think computer science can be done in 45 minutes, 30 minutes, 45 minutes, easily done. Because if you've revised, it can be easily done. Okay, because it's so straightforward. They just give so much excessive information in the questions. I don't know if it helps. Well, it doesn't help for me. I don't know. Maybe it might help you, but I don't think these types of stuff will even help. But let's see actually. Let us see. Okay, we move on. So it says the music company does not want the radio stations to be able to open the music file. Okay, identify 2 security measures and describe how each measure can be used to make sure the music file cannot be opened until the release date. Okay, remember this is over. Is it over online or what? It's not over online, so that would mean you could use a password, and you would say release on the release date, release password on release day. Okay, and then for the security measure 2, you would say encryption. Okay, and encryption would be encryption is simply converting normal data into ciphertext, and you can give the encryption key on release date. Okay, so that is easy 4 marks. Okay, this question you need to know. This is the only thing you need to know about HTML mainly. You need to know the definition of HTML, and then you need to know about structure and presentation. Let me quickly just drink some water. 1 second, guys. So yeah, that's the main thing you need to mainly know for HTML. You just need to know about some examples of structure and presentation. Okay. Okay, we begin. We move on. What's the time? Okay. Explain what is meant by HTML structure and presentation and give an example. So this is a good question. Good question for revision. Structure. The difference between structure and presentation is presentation is the style. Okay, structure is the layout. Okay, structure is the layout of the web page. Okay, presentation is the style of the web page. Okay, an example for structure would be placing an image like somewhere on the web page. For presentation, we have font color, stuff like that. Borders. What is the definition of HTML? So what you need to know for the definition, anytime they ask what is HTML, you just write the full form, hypertext markup language. Okay, it's usually just one mark if they come. Exactly, so that's what you need to do. Okay. Don't read the definitions to remember, read to understand. Yeah, but like, you know, when the exam is tomorrow, then, you know, there's no point. So advantages of DVD. There is no advantages for DVD. But we talked about it in the did we talk about, yeah, look here, DVD. Okay, so DVD is red laser, Blu-ray is blue laser, and then DVD has 2 layers. Okay, and then Blu-ray has 1. Yeah, that's the differences mainly. Move on to this question. Priya uses cookies in her website. Cookies are what? Cookies are simply just packets of information that stores the personal data, that stores the personal data of someone, of the user. Okay, so let's go over this. So you can see we've only done like 2 past papers and we've covered almost all topics, so this is quite effective. So yeah, let's move on. So cookies can be used to store a customer's credit details. That's true, it can. I mean, it can, right? Because that's part of personal data, so it can. Cookies can be used to track the items of a customer which is viewed on the website. That is correct. That is again storing something. Cookies will corrupt the data? No, it will not corrupt the data. Okay, and usually even when you go to the website, usually what I say that you get a notification saying that this site uses cookies. So even someone who is doesn't want to put any information can say no, you know, that they can leave the website. Cookies are downloaded onto a customer's computer. Is it downloaded? Yes, it's downloaded. Cookies are downloaded. If they visit the web page, then it downloads. Cookies can be deleted from a customer's computer. Yes, you can. So quite straightforward, very easy, 5 marks. I love these questions right here. Parallel duplex, such an easy question. Like, look, for this question we have 4 marks. Okay, you need to define what parallel is, and then you need to define what duplex is. Okay, I'm not going to write everything, but look, parallel is several bits over several wires. 2 marks, done. Duplex is both directions at the same time, gives another 2 marks, and you're done. As simple as that. So you can see how easy that is. So that's 4 marks just for almost like not even a line. Okay, so not even a line. So we move on. See what is meant by URL. When it's 1 mark, you can just write the full form. Universal resource locator. Okay, I'm not even going to write that. Okay, but let's just do it for the sake. Universal resource locator. Okay, yeah. Priya is concerned about the DOS occurring on a web server. What is the DOS? 4 marks for this. Usually if they ask 2 marks, but this one is 4 marks. So let's see what points we can do. First of all, the DOS is several multiple requests on the web server, which makes the web server crash. Okay, because of the so many requests. Because of that, it crashes, and then it struggles to respond to the request, and then it just fails. Okay, so let's see. So you could say large or many requests sent. Okay, then you say at the same time. You can, that gives you a mark, at the same time. Not okay. Then you would say web server crashes, and unable to respond. Okay, because when it crashes, you can't respond. So if it's 4 marks, you really need to think here. I won't be straightforward. Yeah, not universal. Oh wait, yeah, it's uniform. My bad. Yeah, uniform. My bad. Yeah, uniform resource locator. My bad. Uniform resource locator. Yeah, that's correct. Sorry about that. Okay, so hopefully that helps. Okay, we move on. Give one security device that can be used to prevent the DOS. That is the firewall or the proxy server. So we can write any of that. And sometimes if they ask you to describe the proxy server, okay, you can also describe how the firewall works, because I've seen, right, when I was doing a post paper, right, they told me to explain what proxy server is, and the marking scheme just was explaining what a firewall is, so you'll get that correct. Even so, whenever it tells you to whenever it tells you to describe what a proxy server is, you can describe what the firewall is, because they're the same thing. They're almost the same thing. Do we need to know about DRM and SRM? Yeah, I mean, you never know. You never know, they can ask it. I know in the older papers they've asked that, so it's always good to know about that, but rarely tested. Again, rarely tested, but you never know. Okay, they'll come in one mark and mess you up, so you never know. More knowledge is always good. Okay, here comes the favorite 6 easy free marks, because you see, these types of question, I want you to learn the format. It's almost the same thing again and again and again. So these are the easiest 6 marks and 7 marks you can ever get. Okay, this is how you do it. I'm gonna keep explaining this whenever it comes. First things you need to know: the sensors, or in this case light sensors, you need to specify send the data to microprocessor. Then the next step you always do: microprocessor converts data from analog to digital with ADC. Next thing, compares preset value. Okay, almost the same things again and again. Compares preset values. Next thing, now you read the question. Actually, I didn't read the question, but now you read the question and you say, if there's no movement detected for a period of 2 minutes, then the lights are switched off. Okay, so here is when you say, if value match of the whatever, then actuator switches off light. Remember, it's the actuator only. Okay, can you solve the 2023 specimen paper? Yeah, I can do that next. Okay, format: sensor to ADC, ADC to microprocessor. No, it's sensor to microprocessor, then the microprocessor will convert the data using the ADC. Then the microprocessor monitors the data. That's correct. Data is checking if present in the range. Yep. Yeah, and then you do the normal stuff. Okay, and then always in the end, always just say that it is a continuous process. That can give you just 1 mark there, which can literally change your grade. So always write process is continuous. You can remember that. Even if you don't see the mark on the marking scheme sometimes, still you can write it. You're never going to get penalized for that. Okay, so that's that. I'm not going to do the entire thing. Now explain what is meant by ROM. First thing you'd say, you would maybe give the full form: read-only memory. Read-only memory. Then you would explain it. Okay, read-only memory, first of all, is non-volatile. Volatile. And RAM is volatile. And then you could also say this is a primary storage. And then you can also say it is directly accessed by CPU. Directly accessed by CPU. Directly accessed by CPU. Okay, so yeah, that's the 3 marks there. Okay, we've done this. Do you guys want me to do the trace table for this? I think it's the same thing, right? It's the same thing. It's almost the same thing. Well, I'll still do it, I think, but it's almost the same thing. Okay, these logic gates questions come like 10 marks. Okay, easy 10 marks there. So don't miss out on logic gates, because they always usually come. Always come. So let's actually just do the truth table, not trace table. I mean truth table. So let's use another color. You can start off with any. So here you would say 1, here you would say 2, here you would say 3, here you would say 4, here you would say 5, here you would say 6. Now the diagram Can you do error checking? I did a question just before. It's easy. Yeah, but even these truth tables, you can make small mistakes. Just do more logic statement trace tables is as okay. Then yeah, let's not do trace tables. Let's focus on the harder ones, right? This one's quite easy. Okay, so let's move on. Yeah, this one's really easy. This is 3 marks again. Parity bit, always 3 marks. Literally, you have to count the number of ones and you get marks for that. So quite easy. So here it says, but you need to know whether it's even party or odd party, and they've made it bold, so even party is used. So you have to make it even. Okay. Okay, let's see. 1, 2, 3, 4, because it's correct. C is also correct. 1, 2, 3, 4. It says B is incorrectly transmitted, so it should be 0. Tricky question there, but it should be 0. No, wait, is it? 1, 2. Oh yeah, no, it should be 1. Should be 1 because it should be odd. So therefore, it should be tricky. Therefore, it should be incorrect. If it's odd number, then it's incorrect because it says they've used even parity. You move on. What is capacitive touchscreen? I talked about this in yesterday's stream, but in simple words, capacitive uses electric fields. Okay, and then you say that sensors are located around the screen, so it uses sensors used, and then finally the coordinates are determined or calculated. Coordinates calculated. And then you could also say when the finger touches the screen, right, it's because of conductivity this works. So yeah, you just explain all that, you would get your marks right there. So we're done with this paper. Any questions from this paper? No, it's not 101, it's actually 111 because when you see this is 1 and 1, which is 2, so 2 plus 1 is 3, and hence why, yeah, I even made that small mistake, but that is that. Okay, any question on this paper? I think this paper was also easy. I can do the specimen paper that someone was asking me to do. Was it specimen? But you see, if it's specimen 2023, then some of it can be out of syllabus, so I really don't want to do it. Okay, because for the people who are doing the paper tomorrow, it won't be beneficial for them, because the specimen paper 2023 is another syllabus. I believe they do some other stuff, like there's a new syllabus. So the people who are doing it tomorrow, it won't be beneficial. So let's not do the specimen paper. Can do another paper. Let's do another paper. We can do one of the 2019 papers still. Okay. Can do one of the 2019 papers. So let's do one of the 2019 papers. I don't think I've done 1.3 2019. I don't think I've done this. Let me just check my channel if I've done this. I really don't want to repeat anything. May, June. Yeah, I don't think I've done this. Yeah, so let's do this. Hey, I have exams tomorrow. I've been watching your videos and they are helping a lot. Glad I'm helping. Thank you so much. Good luck for your exams. Okay, good luck for your exams. Can you revise von Neumann architecture? I made a whole video on that, and also yesterday I was asked that same question. That's why. Yeah. Can you do 2021 May June? I've done it on my channel before. I've done it on my channel before. Yeah, move to another paper. Yeah, we'll move to another paper. Give me a second. Let me also change this counter now to 2. We've done 2 papers. 2 papers in how long? 2 papers, and it's been 78 minutes. You can see that speed right there. You can see that speed. 40 minutes per paper, which is amazing. 40 minutes per paper. Okay, which is really quick. You can see how you don't need all that 1 hour 45 minutes. Okay, we move on. Let's move on. Okay, so we're in agreement that we do this paper. Is this paper fun? Because so many people in between were telling me to do a certain type of paper, and yeah, since I haven't seen any other paper recommendation, if you have any paper you want me to specifically do, you can put right now in the chat. Or is this paper fine? Let me know. let's do this paper. Yeah, since no one has responded, we're gonna do this paper. Okay, this paper should be also easy. Let's see. So it says Victoria is building a website for her cake design business. Okay, and she's using hexadecimal color code. This is the color code as the background color for her website. Okay, the color code is stored in a 12-bit binary register. Checksum is when data is sent, a value is calculated using an algorithm. Yes. And send at the end of the data, and then the receiving end recalculates the check digit. Yeah, and checks it again, the one sent. Yeah, and if they match, then they're correct. If they don't match, they are wrong. Any tips for tomorrow? Know your definitions. Revise conversions. I know they are easy, but still you have to revise your conversions because sometimes you can really mess on them. Then breathe. Okay, yeah, breathe, of course, breathe. And then yeah, go over logic gates, go over the factors affecting everything, go over the different touch screens, go over the different input devices. You'll be good to go. It'll be an easy paper. I have a feeling printers will be on the paper. Yeah, I mean, it could be. It's really easy though. Printers, you only need to know about the two types of printers: laser, inkjet. Inkjet uses piezoelectric, uses thermal bubble, uses rulers. Quite simple. Laser, on the other hand, it's more expensive, uses toner cartridges, so on and so forth. Printers are not hard, man. Printers are not hard. It's just you need to know how the printer works. That's it. 3D printers, again, you just need to just revise that XY plane, uses a cutter, so on and so forth. I'm going to perish if a printer 6-mark question comes up. It can come up saying give the differences between inkjet and laser for 6 marks. So there you would say 3 marks for this, 3 marks for that. But yeah, let's see, we move on. So we have a 12-bit binary register for D2E, and we are supposed, this is hexadecimal, we're supposed to convert it into binary. So you write E here. A is 10, B is 11, C is 12, D is 13, E is 14. So we need to make 14, right? 1, 2, 4, 8. We need to make 14. So 8 plus 4 plus 2 will make 14. Next one, 2. 2 will be just this. Have you seen the paper? I haven't seen the paper. I have no idea. Sealed. I have no idea. But yeah, it should be good. It should be good. Should be good. Okay. Alright, let's move on. So D is what? D is 13. So we need to make 13. So 8 plus 4 plus 1. Yeah. So 1, 0, 1, 1. Simple like that. If you don't understand, okay, can I calculate megabytes to KB by multiplying by 100? Yes, you can. You can use 1024 also. If you're good at multiplication, if you're good at long division, if you have time, go for 1024. Go for 1024. But the easier one would be 1000. Okay, the easier one would be 1000. But if you have the time, right? If you have the time, then 1024 will always be the best option, because in reality that's how you convert. But yeah, you can use 1000. Okay, so yeah, okay, we move on. 3 here we have 5, and then we have F, and we have 3. Okay, so here we have, again, do the same thing, 1, 2, 4, 8. To make 3, you do 1, 1, 0, 0. So you just, oh wait, sorry, not 3. Here it's 5. Okay, sorry. Here it's 5, so you do 4 plus 1, yeah? Okay, F is 15. So 8 plus 4 plus 2 plus 1. It's all of them. And then 3 is just this. If program paper is exempted, will thresholds still be applied while checking the exam? I'm not sure about that. I'm not sure about this new, if you don't do a paper or this, what they're doing with the grid boundaries. But there was an announcement by Cambridge saying that the grid boundaries will be a bit lower than 2019. I mean, sorry, yeah, a bit higher than 2019, but lower than 2021. But let's see. Projectors, I'm not lost. What don't you understand about projectors? It's really easy. The main thing you need to know about projectors, they use many mirrors that reflect light around and they project an image. Yeah. Why is it only 1248? Because in binary, right? It's in intervals of 2 because it's a base 2. All this right now is easy. Yeah, it's really easy. I just have to do it because we're doing the entire paper. You might think it's easy, but then in the exam it comes up and you do a silly mistake by doing a 8-bit instead of a 12-bit. So you never know. Yeah, someone was asking what HTML is, and here's the question. HTML is actually hypertext markup language. Okay, it's only one more. Can you please explain how to go draw a logic circuit? I have a whole video on logic circuit. You see, this was 6 marks, by the way. Yeah, so logic circuits, I've done a lot of them. I did a lot of them in yesterday's live stream, and I've also done some in today's live stream. I've done like 2 in today's live stream. Both the 2 papers had logic gates, so yeah, you can revise that. Okay, so we move on. Here we have a question on structure and presentation. Let's see. A color applied to the text heading on a web page. The color would be presentation. A font size, font style would be again presentation. Remember, presentation is style. Okay, presentation is style. Or am I 1 second. Give me a second. Or the font size uploaded to yeah, it's a presentation because it's style. This one would be all the placement, everything like that. Okay, so here would be placement, paragraph is structure. The size that an image is set to be displayed on, that's again structure. Do we have to build up an HTML coding? What do you mean by that? Is that in paper 2 or what? No. Okay guys, give me 1 second, give me a second. I'll be back in just a minute. Yeah, okay, and then the last one is going to be, sorry, yeah, the last one will be what? The placement of an image. That's again a structure. Wait, the size of an image, size yeah, size is presentation, my bad, size is presentation, and placement is structure. Yeah, yes, there is someone at the door. Yeah, but we're back. Anyway, yeah, let's see how long this live stream will be. 87 minutes so far. Let's see. This is the third paper we're on. Okay, customers will use a web browser to access Victoria's website. Victoria writes a paragraph of text to explain how the web. Okay. So, Victoria writes a paragraph of text to explain how the website will be displayed on a customer's computer. Okay, so this is again fill in the blank. So let's see how this will be. Do 10 papers. Ooh, that's a big goal, but let's see. Will I end this live stream ever then? 10 papers. Let's see. We'll see if I have the energy for 10 papers. Let's see though. A user enters the website. The user enters the website. Let's see, browser. The user enters the website browser into the address bar. Is it browser? No, it's the URL. The protocol that is used is let's see, HTTPS. Those are the only protocols I can see. It's either HTTP or HTTPS. The difference between the two is one is secure, one is not secure. Yeah. But yeah, the URL contains the, what is it? What does the URL contain? The domain name. URL contains the domain name. You need to know the parts of the URL. Remember that. Don't forget the parts. If it comes a question like that, I'll explain that. Okay. An IP address of the company. A DNS server stores an index of IP addresses. The browser sends a request to the web server. As this is where the files for the website are stored, these files are sent back to the browser. It goes back to the browser, and it goes as a HTML file. Okay, remember, web pages are always made with HTML. Did you do the 2021 May June? I've done it on my channel some other time ago. I've done the paper 1-3 right in today's live stream. Yeah. Okay. We move on. Okay. Can I use Python in paper 2 algorithms or pseudocode? You could use Python. But if the question says you can use programming statements, that's when you can use it. But if it says only give in pseudocode or flowchart, that's when you only give in pseudocode or flowchart. And flowcharts are honestly usually harder according to me. Like, they're not harder, but they're just more time consuming. So the best option would be pseudocode. It's more easier, it's more fast, it's more efficient. Explain what's meant by cookies. Cookies are a packet of information that stores the user's data. I'll give you a mark. Small packets of data that is stored by the web's browser. So small packets of data that is stored by the web browser. The browser stores it, not the server. Okay. What is the difference between SSL and TLS? TLS is just more modern. Yeah. TLS has two types of layers, which is record layer, handshake layer. They don't both have handshake layer. It's only TLS. Okay. But if they tell you what is TLS, you can always just define that. Yes, SSL is outdated. We move on. Explain why Victoria would use cookies as part of her website. Why would you use cookies? First of all, cookies, what does it do? It stores data. So it will store customers, let's say credit card details. Then it will also store and password. So you don't have to keep remembering that. So they don't have to remember. Okay, and can be used to track what the customer has viewed, or yeah. As viewed. I should give you 4 marks. The only thing you need to know for cookies, okay, only thing you need to know for cookies is, first things first, what it means, which is a small packet of data that is stored by the web's browser. Next thing you need to know, that it stores credit card details, passwords, so they don't need to be re-entered. Okay, and then it also, you could tell what the customer has viewed. Okay, so yeah, that is the main one. A computer can have both MAC address and IP address. Okay, 4 statements are given about MAC addresses and IP addresses. Tick to show whether each statement is true or false. A MAC address is unique to computer on the network. Is it unique? It is unique. Once an IP address has been sent, it cannot be changed. It can be changed. Okay, MAC address is made up of a computer serial number and IP address. That's wrong. The MAC address is made up from the manufacturer ID and then their own, I think, the device ID. Okay. So people are saying the cookies don't steal any data, right? It just stores the data, so it's completely safe. Okay, but then there's been a question on this paper, on a past paper, saying why someone wouldn't trust cookies, because it could be unsafe. It could be taking the data. You don't know that, right? If the website is fake, that's how they steal the data. Like, for the one when we were talking about fishing and farming, it redirects you to another website. You know, in that website, if they ask you for cookies and then you start putting your credit card information, that's how they steal the personal data. That is how they steal the personal data. So yeah, that's that. Okay, so if a computer does not have an IP address, it cannot communicate with another device using the internet. What? No, wait. If a computer does not have an IP address, it cannot yeah, it cannot. Because IP address, you need it, right? You can't use the internet without the IP address. IP address has to be there. Do we need ethics? I haven't really seen ethic questions. What do you mean you haven't seen ethic questions? They always come. They always come. They always come. Ethic questions, we have done so many ethic questions. All this is actually ethic questions. Like if you cookies, you know, all that is all ethics. All this is ethics. I mean, like, I know it is, but this is all part of ethics. Explain what is meant by the stored program concept. Okay, now the stored program concept is basically when things are executed or programs are executed line by line, one after the other. That's what program concept means. Okay, so these programs are stored in memory, okay, and then they're executed. The instructions are fetched and executed one after the other. So you could say data is stored in a memory. Okay, and then you'd say instructions are fetched and executed one after the other. The other. Yeah, that should be fine. That should be fine. Does Z notes have enough info? No, it doesn't. Z notes is really brief. Like, it's okay for like 5 minutes before the exam because it's really brief. Isn't ethics about plagiarism? No, that's part of it. Ethics is plagiarism is part of that. Copyright part of that. There's so much under ethics. There's hacking, there's viruses, phishing, farming. That's all ethics. There's a whole topic about ethics, and they usually come. Okay, so yeah, von Neumann was a person's name, and he invented this cycle that we have the RAM, the ROM, the secondary devices, and then the ALU, the CPU, everything. The CPU is where the ALU and everything is. So it's a whole cycle. It's just a cycle that keeps going on and on and on. Okay, so that's how it really works. That's the von Neumann. Can you explain phishing and farming? Okay, so phishing and farming. So the main difference between, or let's first go, individually. Phishing is a legitimate looking email that redirects the user to a fake bogus website. Farming, okay, is malicious code that is installed into the computer that redirects the user. So that's the two differences between the two. Okay, that one is a code, one is as in form of an email. Okay, they can ask you between the two. Okay, describe the role of ALU. Remember, ALU, first things you would always say is that it carries out calculations. That is the most easy one. Carries out calculations. Okay, and then it also says it carries out logical operations. The ALU does all the logical operations. Another thing you need to know is that the ALU holds the data temporarily in a register called the ACC. The ACC, I think, accumulator is called. So it holds data temporary in the ACC. That should give you your 4 marks. So for von Neumann, the trick to von Neumann is you just need to know each of the registers and you'll be good to go. Mainly that's it. Are calculators allowed? No. Calculators are not allowed. What are disks? Gotta be specific. What are disks? We have CDs, DVDs. They all use red lasers. The way a disk works, it has pits and dumps where the data is stored. It moves in a circular motion, and then it uses red laser. Okay, so that is what it is. Okay, the computer has an operating system. A signal uses the operating system to stop the and assess what to do next. Identify this. This is called the interrupt. Say two functions of the operating. So we have multitasking Okay, we have multitasking, and we have there's so many actually. We have batch processing, provides an interface, manages users accounts, all that would work. Manages users account. There you go. Okay. So yeah, can you go over logic gates? Is there any logic gate question here? You want me to go over this question? Can't go over it. Yeah. The logic gate questions are quite, they're not that hard. They're not that hard. So we'll come to that question. Just give me a moment, right? The logic gates question is coming in just some time. Wow, this is only question 4 and we're almost done with the paper. Wow, it's page 8 and it's only question 4. So yeah. Explain how a firewall could prevent this distraction. Okay, for a firewall, all you need to know is, first of all, it will monitor the incoming and outgoing traffic. Second of all, the firewall, it will, if it matches, okay, it checks the preset, it checks the criteria. Okay, it checks the criteria, and if it doesn't if it doesn't match it, then it is black. It's called, then it blacklists it, or it blocks access to it. Okay. And then the firewall just examines the traffic, and then yeah, that's the main thing about it, and then keeps a log of all attempts to access blocked websites. I'm not gonna write that, but that should be fine. Yeah. Describe how data is encrypted. So whenever encryption is talked about, so you say data ciphertext. Okay, data to ciphertext. And then you talk about this ciphertext uses something called, it uses an encryption algorithm. Okay, it scrambles the data. At this point, I'm just only giving the points, but of course you would give the entire thing. Okay. Yeah, but 4 marks meaning 4 points. That's how you do any question. 4 marks meaning 4 points. Okay. Yeah, so it scrambles the data. Then what else can you say? What else can you say? A key is used. Yeah, we could talk about that. A key is used to encrypt data. Yeah, that should be 4 marks then. Quite easy. Is that fine? I spent 2 years for Netflix, but now I'm revising. Well, you would still get an A star. Even till up to now, I still believe you can. Just put your mind towards it. You know, computer science is quite easy. But yeah, I mean, you know, for computer science, it's mainly, you know the theory or you don't know. That's how it works. Okay. So what is spyware? Spyware, basically it manages, it looks at key presses, it looks at all of that. So that's what spyware means. Okay. So the main thing about spyware you need to talk about is that the user could have been sent an email and linking to the spyware. Then the spyware records the key logs on the user's keyboard. These key logs are analyzed, common pattern is found, and then it is basically executed. Okay, so that's how it works. That is how it works. Okay, so I'm not going to write all that. That is 6 marks. Okay, so you need more points. Then another thing you could say is that user could have clicked on this and then it will be redirected to another website, and then when they start putting the information, that's how the data is being stolen. So but the main thing for spyware is that it monitors the key presses, so it monitors your keyboard. Okay, and that's how it's done. Now here someone was really requesting for logic gate, so here we go. This is a logic gates question. Oh yeah, I've done this question. I did this question yesterday, so I don't think I'm going to do that again. There's no point of doing the same question again. So I did this question just yesterday. Okay, but yeah, so the main idea is you draw the truth tables for both of them and then find one of the logic circuits. That's how it works. Okay, that's how it works. Okay, so we move on. We've done the same exact paper. If you want to do this, go check out yesterday's live stream. I did the same exact question. Describe the purpose of a logic gate in a logic circuit. Okay, this is a really uncommon question. Okay, but logic gates, it completes a circuit, so it carries out a logical operation and helps to control the flow of electricity throughout the logic circuit. Okay, explain the truth table. I've done the same exact question yesterday's live stream. You can try to find it. Okay, try to find it. That's why I don't really waste time on stuff that I've already done in like just I do CS papers in less than an hour. You can even do it in 30 minutes actually. It's really, it's quite simple. Anyway, okay, the binary number has been transmitted incorrectly is in which one? So it uses which parity bit? It uses okay, so 1 1 2 3. So basically it uses either 1 2 3 4. Yeah, okay, sorry about that. So here you can see it uses is it 5? Sorry, 5 I meant. Okay, so here it uses 1 2 3 4 5. Here it uses 1 2 3 4 5 6. Here it uses 1 2 3 4 5 5. So therefore register B is wrong. It's quite easy because you just have to just count the number of ones. The explanation is wow, 4 marks for that. Okay, 4 marks for that. So first things you would say, you add up the number of ones. With a parity bit, 2 registers have odd numbers, one of them have an even number, then odd parity must be used, so hence even parity is wrong. That's what you do for this question. Describe how resistive touchscreen registers work. So resistive, okay, we have 3 types of screens. Resistive has multiple layers, and once when you click on one layer, it touches the other layer and completes a whole circuit. So it creates a circuit. Okay, and then a calculation is carried out on where you have touched it, and that's how it is done. How is IGCSE Computer Science weighted? Like how many points is 1 mark? What do you mean by that? I think it's a 75 mark paper, the other one is 50 marks. They add them together, they use the grade boundaries, and that's how they weighted. I think if that's what you meant. Identify 2 other output devices. A screen is an output device. Okay, another one would be a speaker, printer, and it would work. Statement what is meant by primary and what is meant by secondary. Now primary storage, okay, the main difference is that it is directly accessed by the CPU. RAM is volatile, ROM is non-volatile. For secondary, it is not directly accessed by the CPU, and they are both non-volatile. Okay, both are non-volatile. So that marks the end of this paper. Was there any question? I know I rushed a bit on this paper, but like it was quite straightforward. There was a lot of writing on this one. But yeah, done this paper. How long has it been for this live stream? 108 minutes, and we finished 3 papers, so that's quite fast. Someone calculate the average there. Yeah, so that is that. Let me drink some water now. 1 second. I've been straight talking for 108 minutes, so hopefully my voice doesn't go after this live stream, but I'm hoping it helps. I'm hoping it's helping. I know it is, because you see, even tomorrow in the exam it will be questions like this, almost similar. Let's do another paper now. Let's change this counter to 3. Let's change this counter to 3. Papers done. 3 papers done. So yeah, what's the next paper we want to do? What is the next paper? Do we continue the 2019 papers? We continue the 2019 papers. 36 minutes of paper. That's quite good. Yeah, 36 minutes of paper. That's quite good. But again, I didn't write in some of them, so maybe we still go with the 40 minutes because I didn't draw the logic circuit. Otherwise, yeah, quite good though. Let's go over let's go over the November paper. I don't think I've done any November 2019 paper, so let's do that one if everybody agrees. everybody agrees we should do that. So let's do this. One of the papers right here. One of the papers right here. Right here. Let's do this. Let's do this question. Let's do this question. Can you explain lossy compression, lossless compression? Yeah. So the main difference, okay, first of all, whenever there's a compression question, okay, you don't need to spam, I'll answer that. Okay, spamming at this point. Spamming. Okay, but the main difference between the two is lossless, coming from its name, okay, the data is not permanently deleted, but for lossy it is permanently deleted. Okay, then whenever they talk about any compression algorithm questions, you always say that it uses an algorithm. Okay, if it is lossy, then you would say it's permanently deleted. If it's lossless, you would say it's not permanently deleted. Then you should also know that a type of algorithm used could be RLE. Okay, so that is one of the ones. And yeah, that's mainly it. Then you would say that depending on the type of compression, it will basically identify repeated data, and then it removes. Yeah, don't spam, guys. And that's how it's done. Basically, that's a quick summary of that, of the lossy compression, lossless compression. It can come tomorrow's it can come. Okay, so yeah, first question usually gonna be on conversions. Okay, first question usually gonna be on conversions. Okay, yeah, so that's that. I'm drinking some more water. My voice is now getting a bit rusty. It's getting a bit rusty now. But I'm gonna keep the stream going on. Let's see, we're gonna keep this stream going on. Okay, can you do 0, 4, 7, 8, 13 on 15? What does that mean? 13 on 15? What do you mean? Is it 2015 or what? Can you explain the thing about translation with source code? What do you mean? What is it? Translators or what? Translation with source code. What does that mean? Oh, is it a freeware shareware? Is that what you're talking about? 0, 4, 7, 8, 1, 8 May June. What year? What year? Okay, let's move on to this question. Actually, let's just do this 2019 paper. Any paper is almost the same. Like they almost have the same questions. We almost have the same questions. Okay, almost have the same questions. So yeah, let's move on to this question. Let's move on to this question. Okay. Let's do this question. Okay, so we have here printer. People were saying get a question on printer. Here it is. Here is the question on the printer. Okay, can you link the past papers, please? Okay, link as in, okay, let me put it on the chat. Okay, put it on the chat. How will I do that? Let's see, 1 second. This is was it 2019? Wait, 1 second. October, November. Okay, give me a second. I'll give you this. Wait, 1 second. Yeah, you can do this together with me. You can write it on your book, right? Okay, let me put it on the chat. Okay, I've pinned the message. Okay, that's the paper we're doing right now. Okay, you keep reminding me to change it though, because yeah. Okay, here, I mean like the compiler translates without source code. Okay, so the difference between compiler and interpreter, if you're trying to say, is that the compiler will execute the entire code. Okay, it will do the entire code and then give the errors, while interpreter is line by line. Okay, yeah, so let's see. Okay, inkjet printer. Can it print in color? It can print in color. Both of them can print in color. Okay, so we can put them like that. Uses powered toner. Only laser printers use powered toner. Okay, the other one uses something called piezoelectric. It sprays the droplets. Okay, that's the difference. And then laser creates output line by line using printer head. We said that was inkjet. And then this one is laser, uses a charge drum to create the printed image or the whatever. What app do you use to write it on? This is just normal PDF. There's no app. You see, when you go and use an app, like as in when you just go online and open a PDF, there's the option for the pen tool. So yeah, I don't have any app for this. Just use a graphics tablet, and yeah, that's it. 2015 looks so outdated. 2015 is so outdated. Are you sure it's the same syllabus as ours? So I hope you're not doing the wrong questions, because 2015 seems so outdated. Yeah. Okay. Andrew wants to print a single page A4 leaflet. He wants to print 10,000 copies. Can't both of them print in color? Yeah, I put both of them in color. They both can print in color. So he wants to print 10,000 copies. Okay, stay whether he should use inkjet or laser. So now the laser would be better for this because it's faster, more efficient. It can print more. Explain how a 3D cutter is used. Okay, so you can say the design is created by the CAD, something called the CAD, which is a software. Then you could say the material is loaded into cutter, and then uses XYZ planes, XYZ axis because it is 3D. Yeah. Wait, does he want it in hexadecimal? What does that mean? Does a laser also print in color? Yeah, I did that. 2015 is an old syllabus. Yeah, it is an old syllabus. It's an old syllabus. Quite an old syllabus. It's quite an old syllabus. A lot might have changed from then. So be careful you're not doing the wrong questions. Yeah, be careful about that. Give me a second, guys. Okay, do an example from 0984 syllabus. I believe they're the same, isn't it? They're almost the same. Yeah. So I believe they are the same. Yeah. So yeah, 1 second. Yeah, so for 3D cutter you just need to talk about this stuff. Uses a software, stuff like that. Okay. Yeah. I mean, I'm checking the chats again. Can you check questions 3 and 2? 2015, I don't know. Isn't it quite outdated? Yeah, 2015 is quite outdated. Yeah, anyway, okay, let's move on to the next question. So we are supposed to convert binary to denary. So we're supposed to convert this binary into denary. Okay. So yeah. Yeah. Okay. I'm just setting up some stuff. 1 second. Okay, yeah, so binary to denary, that's quite easy. So how you do this is you do it this way. 1, 2, 4, 8, 16, 32, 64, 128. And what you're supposed to do is if you want to make this right here, let me zoom it in a bit. Let me zoom it in. See, my voice is going already. It's only been like what, like one it's been like 2 hours. I don't know how long. Yeah, it's been 2 hours and my voice is already gone. Anyway, but we'll keep the stream going on. So what you're supposed to do is you'll just write this binary digit the way it is here, and then you count the numbers on top. So 64 plus 8, which is 72, plus 4, which is 76, plus 2, which is 78. So the answer here is 78. Okay, move on to the other one, this one again. So it's the same thing. Okay, you just replace the stuff. So in this case it will be the same thing. So it'll be 1 1 1 0 1 1 0 1 1. Here's 256. Okay, then you do 256. You see, the thing is that we're not allowed calculators. Drink water. Yeah, I've been drinking so much. Okay, 256, but I'll do that again. 256 plus 128. So here's when my nice primary math will help. 8 and then 3. So that's 384. And 384 plus 32, which is 6, 11, 416. 416 plus 16 will be 12, 3, 432. 432 plus 4, 436, 437, 438, 439 is the answer. 439 is the answer. You guys can do these questions alongside, so in case I make any mistake, let me know. Okay, let me know. Yeah, I need 256. Okay, let's do the last one. Let's do this last one again. So it's the same thing. You can remember 1 2 4 8 16, but these are just 2 to the power 0, 2 to the power 1, all stuff like that. Can you explain check digit? Check digit is quite easy, because what you have to talk about check digit is that the calculation is done before the transmission takes place. Okay, then it's sent along with the data, then after that in the end of then the thing is recalculated and it compares the two datas. Okay, that is how it works. How is USB serial data transmission? Isn't serial supposed to be only in one direction? You see, USB, right? Bro, you're slow. Okay, you see, I'm answering so many questions as well as doing the paper, so yeah, that's the reason why. But you can go ahead, go in front, and then like if there's any problems you encounter in the same paper, then let me know. Check digit is just a digit on the most right. Yeah, pretty much. Okay, why did I erase that? 1 2 4 8 16 32 64 128 256. Let's checksum. It's the same. Checksum, check digits, according to the syllabus, is the same. Okay, there is a formula for check digit. Okay, and checksum also has its own formula, but they work the same way. Okay, so yeah, so let's do this one. So here we have 1, and then here we have 1 0 2 0. Okay, now here I'll really have to count 1 0 2 0 3 0 4 0 5 0 6 0 7 0 8 0. So that's 3 0 4 0 5 0 6 0 7 0 8 0. So I'll need 512. So 512 plus 1, 513. Answer 513. Yeah, let me drink some water again. Let me drink some water. Stay hydrated. Okay, stay hydrated. I've been talking for 2 hours straight, so I'm kind of going insane. Okay. Why does someone use hexadecimal? There's so many benefits for hexadecimal. It's easy to understand, less prone to make mistakes. That's what you talk about here. So I'm not gonna write all that, but that's what it means. Say the hexadecimal equivalent of the binary value. Okay, so you split this into 4 parts. It'll be 2 1. You do 1 2 4 8, so it'll be 3 plus 8. What's 3 plus 8? 11, which is B. And then this one is 1 2 4 8, so that's 5. This should be the answer. What's the most numbers of bits are going to be asked in the exam? I mean, you never know. I think there was once where they said what is the maximum number of bits that are there in in I don't know, I don't know, I forgot the question, but it can be a lot, it depends. But like, it's fine. I mean, you just have to do the additions and everything. I think the name you have given is wrong. Is it? Is it the hexadecimal? No, it's correct. I think it's correct. To be 5, to be 5 should be okay. Should be okay. So yeah. So yeah. Okay. Just looking at the stream now. Are we talking about Discord? I mean, Discord maybe. Maybe I don't know. For now, I'm just focusing on the uploading YouTube streams. Yeah. Okay. Anyway, explain what is meant by spyware. You see, we've done most of these questions now. Should I not write? Let me just dictate. I think let me just speak so we can quickly go over more papers in a less time. So let's see. Explain what is meant by spyware. So spyware, it talks about key logging presses. It talks about the way that it can steal your personal data with the help of your keyboard. So basically how it works is that sometimes they can send you an email. You click on that email, it redirects you to a website, and then you start putting your personal information, and that's how it steals data. That's how spyware is. I'm just gonna dictate now, so I'm not gonna write. I'm not gonna waste time. Okay. So yeah, so this is a malicious software. It sends data to third parties, and they obtain the stuff. So why is USB serial? If flash drive can transmit data both ways, and we talk about serial being one direction, how can something be serial and full duplex? Now it's just like for serial, right? Okay. Serial is, we are talking about the wire, okay, not the direction. Okay, it's maybe you're getting confused between simplex, but yeah. Can I leak the 2022? I don't know myself, so I wouldn't know. Give me $2,000, I wouldn't do it for $2,000. I don't have it, so I mean, yeah. So I don't know. It's quite late here. Are phishing and spyware similar? No, they're not. Completely different. Look, the difference between phishing and spyware. Phishing will steal okay, I mean, you see, spyware, it will be, the data will be sent to the third party, and then they have to look at the different patterns and then identify what the password is. While phishing, they just get to know the data. Okay, a company uses a web page to log onto an online bank. Identify one method that could be used by the online bank to reduce the impact of spyware. So you could use your biometrics. That's one good way. Biometrics is a good way. Use a biometric device because each body part is unique, and you can also use 2FA. 2FA. And yeah, 2FA should be fine. Okay, describe how a firewall works. This question has come so many times. Firewall incoming basically monitors the incoming and outgoing traffic. The user sets the criteria, it checks the criteria. If it doesn't match the criteria, the website is blocked. If it is, then it is blacklisted. And then also you talk about yeah, so that's what you basically talk about. So it monitors this, then it blocks any traffic that does not meet the criteria, allows to blacklist, whitelist, and then yeah, so on, so forth. So on, so forth. So we move on. State two other methods the company could use to prevent okay, sorry about that. So anyway, the two methods could be proxy server or a password or biometrics. Anything like that would work. Yeah, it should be fine. Should be fine. Okay, we move on. A zoo has an information point. Visitors use a menu to select information about animals. The menu includes 500 different animals. The information is provided only using high definition video and audio track. State one input device that can be used for the information point. A keyboard. Keyboard. would work. Any input device would work. Explain biometrics. There's nothing you need to know much about biometrics except that each body part is unique and hence why it can be a password. Nothing much with that. Okay, so you could use like your finger and your eyes and other stuffs. I don't know. This technology is becoming advanced, man, but at this point we don't even need biometrics. It's all just face ID and stuff like that. So, but yeah, in this syllabus you don't say face ID because the syllabus is a bit outdated. I think they should update the syllabus more often. It's a bit outdated. Yeah, exactly. Biometrics just fingerprints, eye scanner, facial recognition. Yeah. Okay, stage one of the output device, printer. Printer could be like printer, speakers, monitor. Those are the normal ways. Okay, explain or sorry. The video files are used. The video files are stored at the information point, one secondary device. So we know two secondary devices, HDD and SSD. So usually they only ask you those two, or USB drive. Okay. Now here we have something called the quick response code. You need to know the difference between quick response, the QR codes and the barcode reader. Okay. So the main difference between these two is the QR code uses matrices. It's in a more square form. Okay, can you explain free software shareware? I did explain that in the previous live stream, like a lot about that. But in summary, shareware, usually they give you a trial, it's paid, stuff like that. Free software, you have the source code, you have freeware, you have the source code, you can share it, stuff like that. Free software, you don't have the source code and stuff like that. Okay, yeah. So QR codes, you need to talk about the fact that the black part of the QR code reflects less light, white one reflects more. Then you say it is converted into binary. You can say you can use your phone or your camera to scan this. And then you can also say QR code can be saved for future stuff. And yeah, each square reflects light different. Okay, that's the things you need to talk about here. So 4 marks meaning 4 points. Okay, 4 marks meaning the 4 points that you need to do here. Okay, these are one of the easier questions. I'm not going to read this stuff. The top part is usually irrelevant, but let's see. Describe how data is transmitted using half duplex serial. So you talk about half duplex. Half duplex is in both directions but not at the same time. That will give you 2 marks. Serial, you say this is 1 bit at a time over a single wire. Okay, that will give you 4 marks. You can see they're quite easy. So now I'm quite quickly going through all the papers because we've gone over most of it if you've been here for throughout the live stream. Okay, the system uses party bits to check for errors during data transmission. The outcome for 4 bytes after transmission is byte 1, byte 2, byte 3, byte 4. Okay, one of the bytes has been transmitted incorrectly. Identify the byte that has been transmitted incorrectly. So here you just count the number of ones. So here there are 4 ones, here there are 3 ones, 1, 2, 3, 4. Here there are 4. Here is 1, 2, 3, 4, 5, 6. So this is the only one that's odd. So it's byte 2. Identify how I identified this. So first of all, you count the number of ones. Byte 1, 3, 4 are all even. Byte 2 is odd. That means that an even parity bit has been chosen, and hence why byte 2 is incorrect. Okay, and hence why byte 2 is incorrect. So yeah. Yeah, so that's the main thing you need to know. That's 4 marks. Okay. Let me just set this up. Yeah, okay, so we move on. So that's how you identify the byte. Okay, So we move on. Explain one benefit of Ishan compiling the program. Okay, so we have the different types of compilers. Okay. Okay, and we have the compiler, the interpreter, and the assembler. What's the differences between all of them, you might ask? So interpreter, line by line. Compiler executes the whole code. Assembler, low level language. One benefit of compiling the data. One benefit of compiling is that the code will run without the need of an interpreter. You don't need an interpreter, and also the source code is not available. The source code, yeah, will you upload this to your channel? Yeah, I will. Someone explain von Neumann. I've explained it so many times in this stream, other streams. But go over your textbook. That's all you need to mainly know. One drawback is source code will not be available. Source code will not be available. Whenever you compile something, it's not available. Interpreter, you would get the source code, but for assemblers, compilers, you won't. Explain how Ishan will know if he's on a secure website. So we have 3 ways you can check. HTTPS, or there are 2 ways actually. The padlock symbol. That's how you check. How does encryption work? Encryption works by changing the data into ciphertext using an encryption algorithm, and an encryption key is made, then it scrambles the data. That's what it means by ciphertext, and that's basically how encryption works. Now, how does the SSL connection be established? So here you talk about, it makes the data unreadable. For SSL, you talk about certificates. Okay, once when you talk about certificates, you can talk about the authenticity of the certificate. So how SSL works is the browser will ask the server to send the certificate. Then the browser will check the server, so it will check the certificate's authenticity, and then that's how it works. And then basically one of that. Okay, then the web server will send that certificate, then it'll check the authenticity, and then if data sent is encrypted using public key and private key. What is meant by freeware? Freeware. Okay, now freeware is when a type of software license which is free of charge, it is normally distributed without the source code, can legally be shared, copied, but cannot legally modify the code. Only free software can modify the code. Okay, can you say use of laser for barcode? Now the use of the laser is so that the light is reflected in different ways. So for the black, it will reflect less. For white, it will reflect more. That's the reason why we use red laser. Okay. I don't have Discord currently. You can message me on Instagram if you have any problem, anything related to that. Then that's the thing. Encryption link between browser and web server. So basically that's it. Move on. If you have any let's move on. So one benefit of compressing program files. A benefit to compress program files, it will more storage is one of the benefits. So more storage. State whether lossy or lossless compression should be used. The program files for the games are okay. So state which ones. So we'll need lossless because it's a game, isn't it? Hence why you need lossless. Okay. That is why you will need lossless. Let's drink some more water now. How long have I been streaming for now? Okay. How do you answer that? Answer what? Sorry. Is it this one? The program files? That one is just more storage is there for the 4 marks. Or the freeware. Okay, so what we said for the freeware is that this one, the source code is not given. You can share it to people, but you cannot modify it. You cannot resell it. Okay, that's mainly what you talk about. Can you write it down? Yeah, sure. Okay, look, so for the freeware, Okay, you have to talk about the fact that it's a software license. Okay, these are the ones that you can get online. Okay. Okay, then here's the free of charge. It's free of charge. You can download it on the internet. Okay, you can say can legally share it, copy it. Okay, but cannot resell because it's someone else's. You cannot resell it. Okay, where can I learn about party bits? So party bits is just straightforward. Okay, the main thing about party bits is you just count the number of ones, and if it is even, then even number of ones. If it's odd, then odd number of ones. So yeah, that's pretty much it. Okay, logic gates, another classic question. Logic gates. Okay, so here this is what an OR gate. First of all, identify the type of gate, which is an OR gate. Okay, and remember the OR gate is the addition gate. So here it will be 0 1 1 1, simple as that. Okay, okay, let's talk about this one. So here are we multiplying it? Okay, this one I can see it's a XOR gate because unlike is 1 and like is 0. Okay. So this is the XOR gate. Does freeware have copyright? It does have copyright. It does have copyright. That's the reason why you cannot resell it. You cannot change anything. You cannot modify the code. Okay. So yeah, we move on. We've done the same exact question before, and if you go check out my logic gate video, you would see that. So let's not waste time on that. Give two benefits of using a sensor to monitor the benefits of sensors. Let's see, this is also not a quite common question, but the purpose of a sensor would be to work continuous and then avoids human error because it's done by the sensor. Now explain how the instruction is fetched on the von Neumann model. Okay, so you talk about PC holds the address held in the PC sent to the MAR using an address bus, MAR to MDR using data bus, then it's sent to the CIR using the control bus, and then the PC is incremented by 1 and these steps are repeated. That is how it works. Describe what is meant by the HTML structure. HTML means hypertext markup language. Structure means the layout of the web page. So this is the layout of the web page where, for example, the paragraph is placed. Okay. Here we have fill in the blank. Last question. I think I'll end the stream after this question. We did so many questions, so I think it's fair. It's couple. It's enough. And also I have many past paper videos on my channel, so you can have a look at that. So yeah. Okay. The user enters the URL of the website. Okay, the web server uses the DNS, or the browser. Which one? The browser uses the DNS server to look up the IP address. This is kind of the role of the browser. The browser sends a request to the web server and the website files are sent as HTML. That marks the end of this paper also. If you're having problems with conversions MB to GB, yesterday's live stream will be really helpful because I did many questions on that in the start. So check out the live stream yesterday. So that makes it 4 papers, and we call it a day. So good luck, guys. Okay, just stay calm. Just go through all the definitions. Go through your flashcards. Go through everything in the morning, okay, or right now. Do active recall, as in take a paper, look at a topic, write everything you know about that topic, do past papers, all that will help. So yeah, I'll call that a day, and hopefully this really helped you. And yeah, I'll see you guys on another video after your CS exam. So all the best and good luck for your exams.